So, hello everyone. Here, me and my group are going to talk about the mini project. We are under CND with the lecturer Dr. Muhammad Noor. And right now, in my group, which is the first group, we are going to talk about our mini project. These are all my friends in my group. And then, so exactly what are we doing in our mini project? So basically, we are trying to study anything about network, mainly everything that is around us. Because whenever we search on the network, it's basically about connected devices, right? That is what basically we are trying to do. We are trying to explore what applications we can use to scan networks and what can we use how can we use the network to our advantage. In this presentation, we'll talk about the tools and what we do with them, and lastly, what steps we can take to ensure our safety in the digital realm. By the end of the presentation, you will surely know each users of the tool and how to use them. Now we go to Dawood.
So in this one, Introduction to Tools Wireshark. Wireshark is a free and open source packet analyzer. It is used for network troubleshooting, analysis, software and communications protocol development, and education. So we use it for a lot of purposes such as passwords, capture, Google ping, and testing LAN. So in this image, you can see from the picture, we can see the IP addresses and the source and destination. We can also find a protocol here. So next move to next slide. So in this one, we use command prompt on both the virtual machine Windows 7 and host operating system Windows 11. We confirm the packet transfer with Wireshark. So this is me using the ping command of my computer to Google. So move to next slide.
Hi everyone. Today I'm going to share a tool called ENSP, which stands for Enterprise Network Simulator Platform. This tool was made by Boy and it helps students and network engineers to learn how networks work. The cool thing about ENSP is that we don't need any real hardware. Everything happens inside the computer. We can create and connect different devices like PCs, routers, switches, and firewalls. With this, we can build a network and see how everything works together. Now let's look at the picture. Look at the picture, we see the cloud one that stands for the internet or a cloud connection. Around the cloud, there are routers named AR1, AR2, AR3, and AR4. So this picture shows the small networks inside ENSP. It's useful for learning things like how data moves through a network, how to fix problems, how to set up routers and test them. All of this can be done without touching any real devices. Moving on to the next slide, we will talk about another tool called Kali Linux. It's an operating system like Windows, but it's made for cybersecurity work. You can think of it like a command prompt, but with many more features. It has a lot of built-in tools for checking and testing network security. One of the most popular tools in Linux is called Nmap. Nmap is used to scan computers in a network, see which ports are open, find out which services are running, check if the network is secure or not. Let's look at the image. Here someone used a command nmap sp. In the result says port 80 is this usually means there is a server running. It tells us the name and the version of the server, Apache 2.29. This really penetrating testing, where we check if a computer website can be added better protection. So in Linux, help us to test, analyze, and keep network safe from hackers. Thank you, everyone.
Okay, guys, now I'm going to talk about ping plotter. What is this? Ping plotter is a network. That tool that helps identify connectivity issue by running traceroute and ping test. It shows a virtual graph easy detect problems like high latency, packet loss, or running errors. As you can see, is a picture of latency.
Nmap. So Nmap, which is short for Network Mapper, is a free and open source network scanner used for network discovery, security auditing, and and operating system detection. It's used by network administrators, penetration testers, and security professionals to map out hosts and services on a network and detect potential vulnerabilities. In the screenshot, you can see that I scanned a operating system and it detected several ports and their service versions. Also, we can see that the host is up with 0.21 second latency.
Okay, next, I'm going to talk about key CDN IP location. Key CND IP location founder is a free online tools that provides details, geolocation, and network information for any IP version 4 and IP version 6 addresses, including country, city, coordinates, ISP, and host name. Thank you.
Okay, now moving on to the actual content of the case that we are studying. See, in this one, we are using Wireshark to do something that is interesting, which is password capture. It is quite an interesting topic, right? So you can see from the top picture, you can see my email, right? But you cannot see the password. All you can see that is 6 digit. Now, what I did was I entered my email and password in a website that is easily penetrable by using Wireshark and stuff. That one is not encrypted. I disable the encryption in Mozilla Firefox. This one I'm doing it in the Windows 7, the VirtualBox. So when I run Wireshark and I put the filter to only search for HTTP protocol, I can see that one of the packets is from my computer and the destination address. And when I take a look at its description, it can show to me the email. You can see at the bottom right there, the email, and also the password, which is ABC and 987. This is of course not possible if I didn't use Wireshark. You see, this really shows that it's actually dangerous if we don't use something that is end-to-end encrypted. Moving on.
Okay, in this one, ping Google with Wireshark. By using ping command in the command prompt, I ping Google address without packet loss. The command prompt showed a simple output. However, Wireshark captured more information and detected that it was sent at 28 April 2025, which is not possible with just a command prompt. So it gives us more information than command prompt. So moving on to the next slide. So in this one, we are scanning a nearby devices by using a public Wi-Fi. So we are getting this like devices information. If I select one device, I can see the information as well by using like Wireshark. So by using the filter DNS and UDP.port equals 5353 and IP.ADDR EQ 224.0.0.251, I can filter for only MDNS protocol. This allows me to focus on the nearby Apple devices that are collected in the library. So this is probably due to AirDrop connection. So in this, by using Wireshark, we actually get the data as well of the user. So moving on to the next slide. So in this one, I'm using ENSP with Wireshark. So Wireshark can scan these packages and retain more information about each packet. This allows us to know the time and bytes of the data sent, which is impossible to know by command prompt. So Wireshark gives us always more information, but command prompt only gives us the basic one. So moving on to the next slide.
Okay. In short, we can see that IPv6 is not visible when connected with VPN. Under hotspot connection, there are fewer connection and routing may be controlled or encrypted. This shows that VPN are important in canceling connection inside and outside my virtual machine. Okay, next slide. Here, we are using the trace command in CND to trace the path from your computer to Google servers. This command shows that each stop your data goes through from your home to Google servers. This helps check networking and network issues or delays. Thank you.
Okay, so
Let's talk about how computers talk to each other in a network, especially when routers are involved. Look at these pictures. We have four computers, PC1, PC2, PC3, and PC4, and some routers in between. Think of routers like traffic police. They help direct where the data goes. Now we did a test called ping. Ping means we send small message from one computer to another to check if it reaches there or how fast it gets back. First, we ping from PC1 to PC2. It looks 59 milliseconds, which is very fast. That's because PC1 and PC2 are on the same networks, like two houses on the same street. When we ping from PC1 to PC3, it took 140 milliseconds, which is a bit slower because they are on different networks and the data had to go through a router. It's like sending a letter to another town. It takes a bit longer. Moving on to the next slide.
okay, now we move on to the next tool, which is NetSpot. Here you can see there's 5 connection. What I did was I stayed at the mosque and then I can scan for a lot of connections. When I put all the connections, there was almost like 400 connection. No, sorry. In the mosque, there were like 80 connections of different Wi-Fi because for Putranet, there's a lot of places, right? Because although it will look like it's the same name, there's actually a lot of ports around all over UPM. So here I've focused on only 5, which is my own hotspot, the orange one, and then the blue one is Putranet, the purple one is UPM guest, the fourth one is some random person's Wi-Fi. That is why it fluctuates. And the last one is UPM Wazan, which is near UPM Mosque, but it's outside the mosque, so we don't feel much connections. So you can see from all the spikes, the highest one is my own hotspot, which is the name Pukul 400. That's the name of the hotspot. The reason why it's so high is because there's very low latency. You see, I put my hotspot here, is like very close to the computer. That is why the latency is very low, because the connectivity is so high. And then, of course, this one shows that NetSpot can help us identify the SSID, the frequency, the band and the security, and the level of the connection itself. As you can see, my own hotspot has the highest level of connection because it's so close to the computer. Okay, now moving on.
Now let's look at another tool. It's called Traceroute or Tracer. This tool shows us all the steps our data takes to reach website like Google. Each step is called hope, and Traceroute shows how long each hope takes. On the left of the image, you can see the list of hopes. There's all the devices or routers our data pass through. On the right side, there is a graph that shows how much delay or latency there was at each step. This version of the traceroute has GUI. That means the graphical user interface. It makes it easier to understand by using pictures and graphs. The question is, why is this helpful? Because we can see the whole path from our laptop to Google. It proves our data is reaching the right place. Accuracy, it shows each correct stop along the way. Timeliness, it shows the delay is small, around 30 milliseconds, which is very fast. The delay is, if the graph goes up and down, it means the delay is changing a little bit. That's called Jira. In short, this tool helps us see how our internet is working and if there are any problems. Moving on to the next slide.
Okay, now we have a Linux type of command. See, this one I use a Linux type of command. So this is a normal TCP scan. TCP is one of the protocols that we learn of finding the port 80 HTTP and 443 HTTPS. These two are the most common for online connection whenever we use websites and stuff. You see, one of the things that I think we learn in class is about three-way handshake, which talks about the synchronized packet, the acknowledgement packet, and also the reset packet. So you can see from the picture right there, I've wrote a bunch of commands, but you can see from the source and destination thing, what I've done is we have sent a packet. We have sent a synchronized packet to the destination address, and then the destination address will send me back an acknowledgement packet. So my laptop sends back an acknowledgement packet. Because we have synchronized acknowledgement and acknowledgement, it has become a three-way handshake for the whole TCP scan. And then the connection, of course, goes to recheck. Thus, the three-way handshake is complete. Now, moving on, with the same commands and stuff, we are doing a stealth TCP scan. This way, the three-way handshake is not actually completed. So now my laptop sends synchronized packet, and then I get back acknowledgement packet. However, this time there's only two things. See, I don't send back another acknowledgement packet. This way, it's like a stealth TCP scan. Usually, whenever we do a port scanning thing and we don't want anyone to detect, we can do a stealth TCP scan. This way, we don't shows ourselves inside the network. So thus, Nmap and Kali Linux allows us to make the connection vulnerable to port addresses stealthily. This is just a surface of penetration testing. There's a lot more that we can learn, maybe on other semesters, or maybe we can learn some on our own.
So now let's learn how to perform basic host discovery using Nmap. So the SN command is a basic scanning command which represents a ping scan or no port scan. So it tells Nmap to skip port scanning and perform a host discovery to see if it's up. It is useful for network inventory or mapping active machines. From the ping scan, as you can see from the screenshot, the ping scan that I did on the IP address, it can be seen that one host is up and it has 0.28 latency. and it identified one IP address as up in 0.55 seconds. This is useful for quickly mapping live hosts on a network or for reconnaissance. It's also valuable for identifying hosts behind firewalls. How to perform TCP port scan in Nmap. So here we can see some advanced scanning commands. SS command represents a TCP SYN scan. It's stealthy and fast method for determining open ports. SV, on the other hand, enables version detection. SS and SV can be combined to first identify open ports and then gather version information about the services running on those open ports. So it is running OpenSSH. You can also see that port 80 is open and running Apache HTTPD. Port 9929, which is often used by Nmap's own nping eco tool for latency testing or debugging, is also open. Port 31337 is open and it is running a TCP wrapped. OS detection using Nmap is a feature in Nmap that remotely scans a target host and presents details of its operating system if there is a match. So here we can see that Linux 4.19 to 5.15 versions has the highest possibility, which is 93% of being accurate. Nmap uses TCP/IP fingerprinting to infer the OS by analyzing how the system responds to crafted packets. Thank you.
Okay, now let's talk about IP location founder. As you can see, this picture shows two compression between Facebook and malaysia.gov.my. Simply, this slide show how we can find where a website service is located using its IP address. Local site use malaysian.gov.my use Malaysia servers, while the global site or Facebook site use the nearby service to improve the speed up. And also the IP address from the Malaysia is hosted in Malaysia, showing that the government use a local service to improve better access and performance for its citizen. But Facebook, although both IP addresses are located in Malaysia, Malaysia in one website, malaysia.gov.my is a government website hosted locally for a public service, while Facebook is a global platform using CDN infrastructure to provide faster central delivery. Thank you.
Okay, now as a summary of what we have learned in this all mini project, you see, when we are talking about this whole mini project, it's all about the network, right? So there's a lot of things that we actually have learned, such as using the tools itself, and it really shows that we need visibility into clear text traffic, which talks about unencrypted HTTP connections. This is talking about the first content that I showed you, and then the latency assessment by using ping plotter. You can actually see the latency and the discovery of nearby devices by using Wireshark. They can actually scan the Apple drop, and then the port vulnerability using Kali Linux, where you can scan ports and using full or stealth scan. And lastly, we have also the wireless signal analysis. By using NetSpot, we can measure the strength of signals, each and its SSID and the name of the network. And these are just some of the many things that we learned by you doing this mini project.
So we have some recommendations for future network analysis. So we know that a network has many vulnerabilities. We must take the following actions to strengthen its security. Use end-to-end encryption. Always ensure that data is transmitted over the network is encrypted. Use secure protocols like HTTPS instead of HTTP for web applications and enforce encryption for internal tools. This helps prevent attackers from intercepting sensitive information such as usernames and passwords. So next one is conduct regular scanning. Schedule product assessments using tools like Nmap for both full and steal scan. This helps identify open ports, running services, and potential security holes. Pair Nmap with vulnerability scanners such as OpenWest or Nessus to detect outdated software and misconfigurations before attackers do. Spikes, jitter, packet loss, and signal strength in real life. So making it easier to identify and resolve performance and security issues. So the fourth is isolate sensitive traffic. Use network segmentation techniques such as VLANs or VPNs to keep critical systems on separate networks. This reduces the risk of lateral movement if a device is compromised and limits exposure of protocols like MDNS and NetBIOS or broadcast traffic, which can leak valuable network information. So move on the next one. So in this one, we have some citations like where we get this information and everything. So move on the next one. So that's all from us. Thank you.